Welcome back. We've got day 3 here of sequences. All right, let's go ahead and take a look at what day 3 is going to entail. So today, given a sequence as a list, formula, or a picture, you will be able to define it as arithmetic or geometric. So let's go ahead and take a look to see what do those two things mean, arithmetic and geometric. So opening up to our day 3 notes, here we go. So an arithmetic sequence is a sequence is called arithmetic if the pattern can be continued by adding or subtracting. So we have to remember arithmetic is adding or subtracting. All right, and that number that you add or subtract is what we call the common difference. Now, even if you're adding, we still call it the common difference because it's how much the numbers are differing from each other. So the number that you add or subtract is that common difference. Now, if a sequence is geometric, a sequence is called geometric if the pattern can be continued by multiplying or dividing. So to get to the next term, if you multiply or divide, it's called geometric. And that number that you multiply or divide by is what we call the common ratio. Oops, ration. Nope, it's ratio. The common ratio. That's what you're going to be multiplying or dividing by. So let's go ahead, let's take a look to see if we can identify if each sequence is arithmetic or geometric, and then find the next two terms in the sequence. So if we take a look at A, we go 14 to 11 to 8 to 5. So if I think about that, we're subtracting 3, subtracting 3, subtracting 3. So my next two terms, let's take a look. Well, if I'm going to subtract 3 again, my next term would be 2. And if I'm going to subtract 3 again, my next term would be -1. So since I'm subtracting, that means this is going to be an arithmetic. So arithmetic. And our common difference, so if you take a look, what number are we adding or subtracting? That number is a 3. All right, let's take a look at the next one. So if we take a look here, 2 goes to 10, 50, 250. So if I take a look, I'm multiplying by 5, multiply by 5, multiply by 5. So if I want to find the next two, I'm going to go 250. Oops, I'll bring my calculator over here, times 5, and we're going to get 1250. So 1250 is my next. And then I take 1250 times 5, and it'll give me my next one, which is 6250. Okay, so if we are multiplying, that means it's going to be geometric. So this is a geometric sequence. And our common, and this time it would be our common ratio. Our common ratio, so what number are we multiplying or dividing? Well, that would be a 5. All right, let's take a look at our very last. We go 12, 6, 3, 3 over 2. So to get to the next term, it looks like we are going to divide by 2. We're going to divide by 2. We're going to divide by 2. So let's go ahead. We need to find the next two terms. So my calculator, I'm going to go in parentheses 3 divided by 2, so 3 halves. And then I'm going to divide it by 2. Okay, I get 0.75. I can either write 0.75, or I'm going to go math, fraction. I'm going to turn it back into a fraction. We get 3/4. So now I'm going to take that term, 3/4, and I'm again going to divide by 2. And we get 0.375. I'm going to turn that back into a fraction, and we get 3 over 8. Okay, so now let's take a look. So since we're dividing, that's going to be geometric. And let's write down, what is our common ratio? So let's think, what are we multiplying or dividing to get to the next term? Well, we're dividing by 2, so our common ratio is 2. All right, so now let's go ahead and let's take this to the next level. So write the first 3 terms in the following sequences. Identify them as arithmetic or geometric. So let's take a look at our very first sequence. Here we have a sub n equals a sub n minus 1 minus 5, and a sub 1 equals 9. So if I take a look here, I have two a sub n's. So that means this is our recursive formula. So we have a new and an old function. So let's go ahead, let's use this formula to find the next couple terms. So a sub 1 equals 9, that's our first term. So a sub 2 is our new term. So we take our old term, which is 9, and we subtract 5. 9 minus 5 is 4. So then we have a sub 3. I take my old term, I plug it in, and then we subtract 5. 4 minus 5 is negative 1. So my first three terms here are going to be 9, 4, and negative 1. So now that we have the sequence, we have to decide whether it is arithmetic or geometric. So let's think. 9 to 4 to negative 1. So I'm going down by 5, down by 5. So I'm subtracting 5. So that's going to make this an arithmetic. Okay, we know it's arithmetic because we're going to subtract 5. Okay, now let's take a look at our second function, our second sequence. We have a sub n plus 1 equals 1/2 a sub n, and a sub 0 equals 4. So once again, we have our two functions. So this is our new function equals 1/2 times the old function. So let's go ahead and let's find our first three terms. So we're going to start with a sub 1 equals 1/2. Now we're going to take our a naught, which is our starting value, and we're going to plug it in 4. And when we do that, we get 2. And then a sub 2 equals 1/2. Now I take that 2 and I'm going to plug it in. 1/2 times 2 is 1. A sub 3, 1/2 times, and I take my 1, I bring it down, and I get 1/2. So my first three terms are, oops, not 4. 4 doesn't count because that's my initial value, a naught. So I'm starting with 2, 1, and 1/2. So let's think, to go from 2 to 1 to 1/2, are we adding, subtracting, multiplying, or dividing? Well, we're dividing by 2. So this is going to be geometric. All right. Let's try the last one. So here we have a sub n equals 2n plus 3. So there's only one function here. So a sub 1 equals 2, and instead of n, I'm going to take that number and I'm going to substitute it in, plus 3. 2 times 1 is 2, plus 3 is 5. So then I go a sub 2 equals 2, and then inside the parentheses, since this number here is a 2, this number here should also be a 2, and then plus 3. So 2 times 2 is 4, plus 3 is 7. So then a sub 3 equals 2, and now once again I'm going to take that 3, I'm going to put it in my parentheses, 3 plus 3. So 2 times 3 is 6, 7, 8, 9, we get 9. So here our sequence is 5, 7, and 9. So now we have to make the decision, are we adding, subtracting, multiplying, or dividing to get to each term? If I take a look, 5 to 7 to 9, I'm adding 2, which means this is going to be arithmetic. All right, so let's go ahead, let's practice a few different problems now. So number 3, which of the following is an arithmetic sequence? So let's take a look, 2, 4, 8, 16, 32, 64. Now, arithmetic means we're going to add or subtract. Add or subtract. So if I take a look here, 2 to 4, I'm adding 2. Here I'm adding 4, so I'm not adding the same number. So 2 times 2 is 4. 4 times 2 is 8. So here I'm multiplying. Can't use that. If I take a look at number 2, 1, 1, 2, 3, 5, 8, well, we're not adding the same number, so it can't be B. If we take a look here, 50, 45, 40, 30, ooh, here we're going minus 5, minus 5, minus 5. So we're subtracting 5. That makes that our arithmetic sequence. All right, let's try question number 4. Given an arithmetic sequence whose first 3 terms are given by 4, 14, 24. So let's see, can you find the pattern? So what's the pattern? Well, it looks like we're increasing by 10. So explain why the pattern is arithmetic. So why does that make this an arithmetic sequence? Well, because you are adding. Or you could say it has a common difference. So what is the common difference? Well, the common difference is, well, what is it increasing by? It's increasing by 10. So next, what is the 4th term? So our 4th term, so 4, 14, 24, our 4th term would then be 34. All right, what is the 10th term? So let's take a look. So we go 34, 44, so this is a sub 1, a sub 2, a sub 3, a sub 4, a sub 5. So if we were going to go all the way to the 10th term, well, 5 is 44, so I'm going to say a sub 10 would be equal to 94. All right, let's try another one like that. So let's go ahead and flip over. So now let's try this with a geometric sequence. Given the geometric sequence whose first 3 terms are given by 2, 6, 18, can you find the pattern? Well, to me, it looks like we're going to go and we're going to multiply by 3. We're going to multiply by 3. So here we're going to be multiply by 3. So now it says, explain why the pattern is geometric. Well, it's geometric because you are going to multiply. And because you're multiplying, it's going to have a common ratio. So what is the common ratio? Well, what number are we multiplying by? That's right. So the common ratio is 3. So now it says, what's the 4th term? So let's go ahead for the 4th term. So I'm going to take my calculator. And I'm going to go ahead, 18 times 3, 54. So next it wants, what's the 6th term? So this is a sub 4, so we want a sub 5, and then a sub 6. So let's go ahead and let's keep this going. So 54 times 3, 162. And then we go 162 times 3, and we get 486. And that'll be our 6th term. So 486. All right, let's go ahead and try something a little bit different. So let's, instead of looking at a formula, let's look at a picture and see if we can figure out what the pattern is. So part 6, in the following diagram, shows a set of blocks increasing in size. Underneath each set, write how many blocks are in each set. So here we have 1, 2, 3. So here we have 1, 2, 3, 1, 2, and there'd be 1 hidden behind it, so that would be 6. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, there'd be 12. And here we have 1, 2, 3, 4, 5, 6, 7, 8, and there's 3 in each, so that would be 24. So is this sequence of blocks shown depicting an arithmetic or geometric sequence, and explain? So let's take a look. 3 to 6 to 12 to 24. It looks like we're multiplying by 2 each time. So I'm going to say it's geometric because we're going to multiply by 2. So describe how the number of blocks is increasing. Well, I think we just did that. So it's going to multiply by 2. All right, let's go ahead and take a look then at the last one. So number 7, the diagram below represents the first 3 terms of a sequence. Assuming the pattern continues, which formula determines a sub n, the number of shaded squares in the nth term? So if we take a look here, the number of shaded squares, we have 12, 16, and 20. What I'd like you to do now is on your own, I'd like you to go ahead and find which of these gives you a sequence of 12, 16, and 20. So if you want to use your calculator, you would plug it in. 1 would give you 12, 2, 16, and 3 would give you 20. All right, see you in class tomorrow.